All right, let's take a look at the practice test. We want to find the 6 trigonometric functions for our angle theta. So coming down to this first problem, we see we have a right triangle, and a lot of you will recognize this as a 3, 4, 5 right triangle. It's very popular. So thinking about this, if I want to find the sine of theta, the cosine of theta, the cosecant of theta, the secant of theta, the tangent of theta, and the cotangent of theta, what do I need to do? Well, the first thing that I would do if I'm struggling with this type of problem, I would identify where is your opposite, where is your adjacent, and where is your hypotenuse. So we know that with the right triangle, this signature mark here means that this is a 90-degree angle. And the side that is opposite of your 90-degree angle, that's your longest side, that's called the hypotenuse. Let's just say this is HYP. Here we're given this length 5, okay? So I'm just going to put right now that the hypotenuse HYP, let's say that's equal to 5. Now, we are dealing with this angle theta here, so everything is in terms of that. When I think about the opposite side, it's going to be this guy right here, right? This is opposite of this angle theta. So let me put OPP right there, and I'm going to write OPP is equal to 3, and that just stands for opposite. And then the side that is adjacent to this angle theta, that has this length of 4. Let me put ADJ for adjacent. So ADJ is equal to 4. So just using these numbers here, you can set up your ratios. And so I'm just going to start with my sine of theta. So what's that equal to? Again, if you struggle with memorizing this stuff, you can use the SOH and then CAH and then TOA. Okay, so this is very popular. The S stands for sine, and the O is opposite, and the H is hypotenuse. So the sine of theta is opposite, so opposite over hypotenuse. And you just fill in what you have. The opposite is 3, and the hypotenuse is 5. So this is just 3/5. You can get rid of this if you want. You don't need it. It's just for scratch work. I'll just say my answer here is 3/5. And then for the reciprocal of this guy, your cosecant of theta, just flip this. It's 5 over 3, or you could say it's the hypotenuse over the opposite. Right, so it's just the reciprocal. All right, for the cosine of theta, we think about this CAH part here. So the C is for cosine. Let me write cosine of theta here. And basically, it's the A here is the adjacent, and the H here is the hypotenuse. So it's just the adjacent over the hypotenuse. So the adjacent is 4, and the hypotenuse is 5. So this is going to be 4 over 5, or you could say 4/5 if you wanted to. And the reciprocal of this is the secant of theta. Again, just flip this. It'll be 5/4. Right, so in that case, it's going to be the hypotenuse over the adjacent. All right, then lastly, we're going to find the tangent of theta, and we're going to find our cotangent of theta. Now, the T is for tangent, and this is opposite over adjacent. So the opposite is 3, and the adjacent is 4. So this is 3 over 4. Then for your cotangent of theta, you're just going to take the reciprocal. So the reciprocal of 3/4 is 4/3. With the cotangent of theta, it's just the adjacent over the opposite. So not very hard overall. What you want to do if you're struggling with this, write out your SOH-CAH-TOA, set up your ratios, get them all lined up, and then go through and label the parts of the triangle so you're not lost. And then you can just plug in and you'll be good to go. All right, let's take a look at problem number 2. So we have another right triangle. We're trying to find the values for the 6 trigonometric functions. So again, I would just label everything first if you're struggling. This is your right angle here. Again, it's 90 degrees. We know that. And so the side opposite of that is going to be your hypotenuse. That's the longest side. So let's label this as HYP for hypotenuse. And you can write over here that the hypotenuse is going to have this length, which is 25. And then if you think about this angle theta that we're working with, the side that is opposite of this angle is this guy right here. So I'm just going to say this is OPP for opposite. Let me put OPP. And I'll say that length is going to be 7. Right, that's given there. Then the side that is adjacent to this angle theta, let me put that right there. So this is our adjacent side, and the length is 24. So let me put ADJ is equal to 24. Okay, I'm going to go down here. Our little triangle is going to be off the page, but we don't really need it anymore because we have all the information. So again, if we're trying to remember how to find sine or cosine or tangent, we can use the SOH-CAH-TOA. Okay, everybody uses this. So for sine of theta, remember it's opposite over hypotenuse, and you can write that out, or we could just say opposite is 7, and hypotenuse is going to be 25, so 7 over 25. The cosecant of theta, again, you're just going to flip this. It's going to be 25 over 7. Here you have your hypotenuse over your opposite. Now for your cosine of theta, again, you just go to this guy right here. So the C stands for cosine. It's adjacent over hypotenuse. So your adjacent is 24 and your hypotenuse is 25. And then if you want the secant of theta, we're just going to flip this. So it's 25 over 24. So in this case, it's the hypotenuse over your adjacent. Now, for the last two, we're going to think about tangent and cotangent. So for the tangent of theta, again, just look at this t here. That's for tangent. You have opposite over adjacent. So the opposite is going to be 7. Your adjacent is going to be 24. Then again, if you want the cotangent of theta, you're just going to flip this. So it would be 24 over 7. In that case, it's adjacent over opposite. All right, let's take a look at problem number 3 now. So again, we're trying to find sine, cosine, tangent, and then your reciprocal. So cosecant, secant, and cotangent. So thinking about this, again, if I identify where the 90-degree angle is, I know the side that is opposite of that is going to be this guy right here. So that's my hypotenuse. That is my longest side. Again, you could just write that the hypotenuse, HYP for short, we'll say the length is 15 there. Okay. Now we're dealing with this angle theta here. So opposite of that is going to be this guy right here. So this is your opposite side. Let me put that down there. And the length is given as 12. And then the adjacent guy is going to be this guy right here. So maybe I'll write it like this. So ADJ. So ADJ for adjacent. And the length there is 9. All right, so thinking about the trigonometric function values, again, you could just write out the SOH-CAH-TOA. Okay, just do this a few times and you'll memorize it. So if you think about, again, sine of theta, so sine of theta, it's going to be what? Here's the S, it's O and then H. So O is opposite, H is hypotenuse. So the opposite here is 12, the hypotenuse here is 15, and essentially you have a common factor of 3. So 12 divided by 3 is 4. And then if you think about 15 divided by 3, that's 5. So this is 4/5. And if you have the cosecant of theta, again, just flip this. It's the reciprocal, so it's 5/4. Again, the cosecant of theta is going to be your hypotenuse over your opposite, right? So just in a different order. All right, for the cosine of theta, this is equal to what? Well, again, here's your C. You have the A and then the H. So the A is for the adjacent, the H is for the hypotenuse. So the adjacent is 9, the hypotenuse is 15. You have a common factor of 3. 9 divided by 3 is 3. And 15 divided by 3 is 5. So this is 3 over 5 or 3/5. For your secant of theta, this is the reciprocal of this, so 5/3. Again, that's going to be hypotenuse over adjacent. Now, let's think about the last two. So you're going to have your tangent of theta. And again, that's your T here. You have O and then A, so opposite over adjacent. Opposite here is 12, adjacent here is 9. So 12 over 9, and again, you can cancel a common factor of 3. So this would be 4 if you divide 12 by 3, and this would be 3 if you divide 9 by 3. Okay, so you get 4/3. And then for the cotangent of theta, I'm just going to take the reciprocal of this, so it will be 3/4, right? So in that case, it's the adjacent over the opposite. All right, let's take a look at problem number 4 now. So again, we're trying to find our trigonometric function values. Here's our right angle. Let me just put in here that this is 90 degrees. So opposite of that, that's this guy right here, that is your hypotenuse or the longest side. So let me write over here that the hypotenuse, or actually I think that's going to get in the way because maybe people will think I'm labeling that as a hypotenuse. Let me slide down here a little bit and put hypotenuse. I'll put the length for this is going to be 14. And then we're dealing with this angle theta here. So opposite of that is this guy over here. So let me put OPP for opposite. And then for the opposite, the length is given as 4. And then this guy right here is going to be adjacent. So let me put ADJ for that. So this is adjacent, and the length is 6 times square root of 5. So now that we have all this information, we can actually go past this image here. We don't need the triangle anymore. I'm just going to write out the SOH-CAH-TOA, so we can use it real quick. So if I think about my sine of theta, that's going to be what? You have your O and then your H, right? The S stands for sine. So O is opposite and H is hypotenuse. So the opposite is 4, the hypotenuse is 14. So 4 over 14, cancel a common factor of 2 between numerator and denominator. 4 divided by 2 is 2. 14 divided by 2 is 7. So you get 2 over 7. Then for your cosecant of theta, again, just take the reciprocal of this. It's 7/2. Again, in that case, it's the hypotenuse over the opposite. Now, you go to your C, that's for cosine. So for the cosine of theta, this is going to be what? The a and then the h. So the adjacent over the hypotenuse. So you have 6 times square root of 5 over 14. And between the numerator and denominator, you have a common factor of 2. 6 divided by 2 is 3. 14 divided by 2 is 7. Now, I'm just going to flip this, or again, find the reciprocal for my secant of theta. So that gives me 7 over 3 times the square root of 5. But I need to rationalize the denominator here. So I'll multiply this by the square root of 5. And I'll multiply this by the square root of 5. So that would give me 7 times the square root of 5 over 3 times 5, which is 15. Okay, so that would be my answer. And then lastly, I need the tangent of theta. So the tangent of theta, and again, that's the t here for tangent. You have O and then A. So opposite, which is 4, over adjacent, which is 6 times square root of 5. And let me come down here a little bit. I'm going to run out of room. So between numerator and denominator, you have a common factor of 2. So if I divide 4 by 2, I get 2. If I divide 6 by 2, I get 3. Now I'm going to rationalize the denominator, but before I do that, I'm going to write out that the cotangent of theta is the reciprocal of this in this form. So 3 times square root of 5 over 2. If I rationalize the denominator first, when I flip it, I'm going to have to rationalize the denominator again when I get over here. So I don't want to do that. So I'm going to multiply this by the square root of 5 over the square root of 5. So that would give me 2 times square root of 5 over 3 times 5, which is 15. So 2 times the square root of 5 over 15. All right, for the next few problems, we're going to write each function in terms of its cofunction. So we discussed this in the lesson. For problem 5, we have the cosine of 51 degrees. So we know that the cofunction, when we deal with cosine, is going to be sine. So we know that the cosine of some angle theta, where theta is going to be some acute angle, this is equal to the sine of 90 degrees minus this angle theta. Okay, so this is always true as long as this theta here is an acute angle. So what we'll do here is write this in terms of this sine guy. So we'll say this is sine of 90 degrees minus our angle here is 51 degrees. That's all we're really doing. And so 90 degrees minus 51 degrees is 39 degrees. So you could write the cosine of 51 degrees as the sine of 39 degrees. All right, for problem number 6, we have the cosecant of 19 degrees. So to rewrite this in terms of its cofunction, again, cosecant and secant are cofunctions. So what I'll do is say this is equal to the secant of, again, take your 90 degrees and subtract away this angle, which is 19 degrees. And so 90 degrees minus 19 degrees, that's going to be 71 degrees. So let's say that we can write the cosecant of 19 degrees as this secant of 71 degrees. All right, for problem number 7, we're given the cotangent of 77 degrees. So the cofunction with cotangent is going to be tangent. And so to write it in terms of its cofunction, you're going to say this is equal to the tangent of, again, go 90 degrees minus this angle measure, which is 77 degrees. So 90 degrees minus 77 degrees, that's going to be 13 degrees. So we're going to write this as the tangent of 13 degrees. All right, let's take a look at problem number 8. So we have the secant of, you'll have this quantity for your angle measure. So theta plus 15 degrees. Again, we're going to assume that theta plus 15 degrees is some acute angle. So recall that if you have the secant of some angle theta, we'll say this is equal to, the cofunction here is the cosecant. So the cosecant of this guy 90 degrees minus theta. Okay, so setting this up in a similar way, we would say this is equal to the cosecant of 90 degrees minus whatever this is. So I'm subtracting this whole thing away. So I'm just going to make sure to use parentheses here so I don't make a sign mistake. So I'm subtracting away theta plus 15 degrees. Let me get rid of this. And let me just write this on a new line so nobody's lost. So we're saying the secant of, you're going to have this theta plus 15 degrees like this is equal to the cosecant of, well, we know this negative would be distributed to each. So let me get rid of that from there. So you have negative theta and negative 15 degrees. So this would be 90 degrees minus 15 degrees, which is 75 degrees, and then basically minus theta. So this is how you could write this in terms of its cofunction. And you could play around with some simple angle measures if you wanted to. For example, let's just say, for simplicity, I let theta be 10 degrees. So then you would have the secant of 10 degrees plus 15 degrees is 25 degrees is that equal to the cosecant of, well, if you had 75 degrees minus 10 degrees, that would be 65 degrees. And yeah, we're good to go. Remember, this 25 degrees plus the 65 degrees has to be equal to 90 degrees for this to hold, and this is going to be true in this case. All right, for the next two problems, we want to find one solution for each equation. Assume all angles are acute angles. All right, so looking at problem 9, we have this sine of 3 theta minus 6 degrees. This equals the cosine of 5 theta minus 48 degrees. Again, we want to figure out what is theta, okay? So what you would do here is realize that, again, if you have the sine of some acute angle theta, this is equal to the cosine of 90 degrees minus theta. But if you think about the sum of this plus this, it's going to be 90 degrees. You could say theta plus your 90 degrees minus theta. Well, if you add all that together, you're just going to get 90 degrees, okay? So that's what I'm looking for as a sum from this part right here plus this part right here. Okay, so that's going to allow me to solve a simple equation. I'll say 3 times theta minus 6 degrees plus 5 times theta minus 48 degrees is equal to 90 degrees. Okay, let's slide down just a little bit. And what I'll do here is say that 3 times theta plus 5 times theta, that's 8 times theta. And then negative 6 degrees minus 48 degrees, that's going to be negative 54 degrees. And then we have this is equal to 90 degrees. Let's add 54 degrees to both sides of the equation. Let's cancel that away from over here. And what you're going to have is 8 theta is equal to 90 degrees plus 54 degrees. That's going to be 144 degrees. As a final step, let's divide both sides of the equation by 8 so that we can isolate theta. And so this is going to cancel. And you'll have theta is equal to 144 degrees divided by 8 would be 18 degrees. Now, what I like to do with these is come back up and check them and make sure I got the right answer. It's very easy to make a mistake with something new like this. So we're saying that theta equals 18 degrees. So if that's true, then this side should be equal to this side. So we have the sine of 3 times theta. So theta is 18 degrees. 3 times 18 degrees is 54 degrees. And then minus 6 degrees. If we did this calculation, we would have 48 degrees. So this left side would be sine of 48 degrees. So is this equal to the cosine of 5 theta would be 5 times this 18 degrees here, which would be 90 degrees. And then minus this 48 degrees. 90 degrees minus 48 degrees, that's going to be 42 degrees. So this will definitely work. The sine of 48 degrees is equal to the sine of 42 degrees. So this guy is valid. Okay, let's take a look at problem number 10. So we have the cosecant of, you have your theta plus 8 degrees is equal to the secant of 3 theta plus 10 degrees. Okay, so again, this guy plus this guy, that's going to be equal to 90 degrees because the cosecant of theta, where theta is some acute angle, is equal to the secant of your 90 degrees minus your theta. Okay, so if you take this and you add it to this, you get 90 degrees. So all I'm going to do here is take theta plus 8 degrees, then plus 3 theta, then plus 10 degrees, and set this equal to 90 degrees. Okay, so theta plus 3 theta is 4 theta. 8 degrees plus 10 degrees is 18 degrees, and this equals 90 degrees. Let's subtract 18 degrees away from each side of the equation. This is going to cancel. So we have 4 theta is equal to 90 degrees minus 18 degrees is going to be 72 degrees. What I'm going to do from here is divide both sides of the equation by 4. And so this right here is going to cancel. And we'll say that theta is equal to 72 degrees divided by 4 is 18 degrees. So that's our answer for theta. So coming back up here, again, if we want to check, just plug in. So the cosecant of 18 degrees is getting plugged in for theta. So 18 degrees plus 8 degrees, that's going to give me 26 degrees. Let me get rid of this. We don't need this. This is equal to the secant of 3 times 18 degrees, that's 54 degrees, then plus 10 degrees. That's going to be 64 degrees. So is this true? You just check to make sure that the sum of 26 degrees and 64 degrees is 90 degrees. If you punch that into your calculator, this is a true statement. So this guy is going to be correct. All right, let's take a look at the practice test. So we want to find the reference angle for each angle. And for the first problem, we're going to start with negative 520 degrees. We could use this little cheat sheet here, but I think it's probably better to look at a little sketch in case anybody's struggling. So for this one, let's start off with the angle. It's negative 520 degrees. Now, if you have a negative angle, or if you have an angle whose measure is greater than 360 degrees, you want to find the coterminal angle that's going to be between 0 degrees and 360 degrees. So thinking about the sketch of this guy, if I rotate clockwise, because this is a negative angle, one full clockwise rotation is going to be negative 360 degrees, so that's going to put me right there. And then I'm going to go another negative 160 degrees to get right there. Okay, so that would be a negative 520 degree angle if you wanted to sketch it. Now the coterminal angle, the one I want to work with, to find that I would just add 360 degrees and then 360 degrees again to get into the desired range. So that's going to be adding 720 degrees, and that's going to give me 200 degrees. So that's the coterminal angle I'm looking for. So again, same initial side, same terminal side. The rotation just differs by some multiple of 360 degrees. So let's get rid of this. We don't need to think about the negative 520 degrees anymore. We're just going to work with the 200 degree angle. Now, when we talk about the reference angle, we're looking at this theta prime here. It's the positive acute angle made by the terminal side of this 200 degree angle and the x-axis. So when you're working these problems, always think about the x-axis, never the y-axis. So let me draw this in with a ruler. Okay, and that's not perfect, but it's good enough. So I'm just demonstrating that the angle we're looking for is going to be this guy right here. So this theta prime, which is our reference angle. So how do we figure this out? Just look at this guy and think about it. Well, you have a 200 degree angle if I think about this whole thing here, right? But I just want to measure from right here to right here. So what's that rotation? Well, what I could do is take the total rotation, which is 200 degrees, and subtract away the part that I don't want to measure, which is this guy right here. So this amount of rotation right here. And we know that this is a straight angle, so the measure of that is 180 degrees. And so just looking at this guy, I can see that this is going to be a 20 degree reference angle. So if you're in your quadrant 3, like we are there, you take your theta, in our case it was 200 degrees, and you just subtract away that straight angle, which is 180 degrees. So we would say that, again, I'm not going to work with this negative 520 degrees. I'm going to work with the coterminal angle, which is 200 degrees. And then I'm going to say that my theta prime is equal to this 200 degrees minus 180 degrees, which is going to be equal to 20 degrees. So the theta prime, or the reference angle for the negative 520 degree angle, and then also for the 200 degree angle, is going to be 20 degrees. All right, for problem number 2, we have 575 degrees and we want to find the reference angle. So in this particular case, again, we need to find the coterminal angle between 0 degrees and 360 degrees. So let's say we have 575 degrees, then minus 360 degrees, and this is going to give me 215 degrees. So this is the angle I want to work with. Again, if you look at the little sketch, this is 215 degrees. If you wanted to sketch out 575 degrees, it's going to be one full rotation, so that's 360 degrees, and then you're going to go another 215 degrees. So that would be your 575 degree angle. But again, you want to work with this coterminal angle, this 215 degree angle. And thinking about this, we're in quadrant 3, so it's the same rule. I'm thinking about this part right here. Again, take the total angle measure, which is 215 degrees, and subtract away the part that you don't want to measure. Okay, so this is that straight angle there, which is 180 degrees. So if you do this calculation, you're going to get 35 degrees for your theta prime, or your reference angle. So coming back up here, let me get rid of this. Just using a little cheat sheet, we're in quadrant 3. So theta prime is equal to, again, it's 215 degrees for the coterminal angle, minus 180 degrees, which gives me 35 degrees for my theta prime, or again, the reference angle for 575 degrees, or the coterminal angle, which is 215 degrees. All right, let's take a look at problem number 3 now. So we have 295 degrees, and we want to find the reference angle. So here we're okay. We don't need to find a coterminal angle. If you look at a little sketch of this, you'll see that this lies in the 4th quadrant. And so for this guy, again, you would think about now the fact that this right here would be a full rotation. So we know that that's a 360 degree angle. Well, I just want to measure this part right here. So what's that amount of the rotation? Well, all you have to do is think about this guy right here. I don't want this rotation, so I'm just going to subtract it away from the whole thing. So 360 degrees minus the measure of this angle here, which is 295 degrees, that's going to give me the theta prime here, or the reference angle. And in this case, that's going to be 65 degrees. So coming back up here, again, if you're in quadrant 4, your theta prime is equal to 360 degrees minus your 295 degrees, which again is 65 degrees. Okay, for problem 4, we have negative 275 degrees. So again, what I want to do here is add 360 degrees. And so you'd have negative 275 degrees plus 360 degrees. So that's going to give me 85 degrees. And if you're in quadrant 1, like you are with an 85 degree angle, your reference angle is just equal to that angle. Okay, so theta prime here is equal to theta. So theta prime is equal to 85 degrees, right? So if you're in the first quadrant, that's always going to be the case. If we come down to our sketch, again, if you think about a negative 275 degree angle, well, that's going to be starting here, and you're going to rotate clockwise until you get here. Okay, so that's going to be your negative 275 degree angle. Again, if you kept going this way and you added another negative 85 degrees, once you get to this point, you'd be at negative 360 degrees, okay? But we don't want to think about it that way. We want to think about it the other way. So we find the coterminal angle. So that's going to be 85 degrees. And so you can see that this angle right here is the angle we're looking for. So theta prime is equal to this 85 degrees. Let me just write this here. So theta prime is just equal to 85 degrees. It's just equal to the angle that we're working with. All right, let's take a look at the next part of this where we're going to find the exact value of each expression. So coming down here for problem 5, we have the tangent of negative 225 degrees. So the way this type of problem works, you're going to first find a coterminal angle between 0 degrees and 360 degrees if this guy's negative. So with this one, you have negative 225 degrees. Let's add 360 degrees. So this is going to give me what? Well, it would be 135 degrees. So that's the coterminal angle you want to work with. So let's think about this for a moment. So I'm going to say that the tangent of negative 225 degrees will be equal to the tangent of 135 degrees. Now, we look at this guy right here. We talked about this in the lesson where these come from. We don't see the tangent of 135 degrees. This is something you'll memorize from the unit circle later on, but for right now, we're going to rely on this. Well, what you would do is actually think about the reference angle for an angle that's 135 degrees. So the reference angle, again, if I'm in quadrant 2, is going to be 180 degrees minus the angle. So the reference angle, theta prime, is going to be equal to 180 degrees minus 135 degrees. So here that's going to be 45 degrees. Now, the reason I'm using this is because the function values will be the same in terms of their absolute value. You just have to work out the sign using the all students take calculus. So what I'm going to do is think about this angle here is going to be in quadrant 2. So tangent is negative in quadrant 2. So I'm going to put is equal to the negative of the tangent of 45 degrees. When you work with this table here, everything's positive because you're in quadrant 1. So again, because I'm in quadrant 2, I got to slap a negative there. And I'll say this is equal to the negative of the tangent of 45 degrees is going to be 1. So the final answer here for the tangent of negative 225 degrees is just going to be negative 1. All right, for problem number 6, we have the cosecant of 675 degrees. So let's say the cosecant of 675 degrees. So because this is greater than 360 degrees, let's find a coterminal angle that has a measure between 0 degrees and 360 degrees. So if I say 675 degrees minus 360 degrees, I'm going to end up with 315 degrees. So this is my coterminal angle. So I'll say this is the cosecant of 315 degrees like this. Let me get rid of this part right here. So again, I don't have anything for 315 degrees here. So I've got to rely on my reference angle until I can memorize the unit circle. So I'm going to say this is equal to, for cosecant with a 315 degree angle, that means I'm going to be in quadrant 4. And if I'm in quadrant 4, cosecant, which is the reciprocal of sine, that's going to be negative, right? Sine and cosecant are negative in quadrants 3 and 4. So again, I'm going to slap a negative sign out in front because of my rule, okay? And then I'm going to think about the cosecant of whatever the reference angle is here. So to find that, if I'm in quadrant 4, your theta prime is going to be 360 degrees minus your angle, which is 315 degrees. And that's going to give me, once again, 45 degrees. So I'm going to put this up here as 45 degrees. Let's get rid of this scratch work here. And so I can just go into my table. And if I want the cosecant of 45 degrees, that's the square root of 2. But again, I've got to slap this negative sign on it. So this will end up giving me the negative of the square root of 2. All right, for problem 7, we have the secant of negative 510 degrees. And again, I want to think about a coterminal angle that's between 0 degrees and 360 degrees. So let's go negative 510 degrees. I'm going to need to add 360 degrees twice. So let me add 720 degrees like this. So this is going to give me 210 degrees for the coterminal angle. So let me get rid of this, and we'll say that the secant of this negative 510 degrees is equal to the secant of this 210 degrees. And again, I'm just going to think about the reference angle here. This is going to be in quadrant 3. So in quadrant 3, theta prime is going to be 210 degrees, so the angle measure, minus the 180 degrees. Remember, you're subtracting away that straight angle. So this is going to give me 30 degrees. In quadrant 3, is secant positive or negative? Remember, secant is the reciprocal of cosine. So it's going to be negative in quadrants 2 and 3. So once again, I've got to slap this negative sign out in front, and then I'll say this is the secant of this 30 degrees. Let's get rid of this, and let's say this equals, put your negative out in front. Your secant of 30 degrees is 2 times square root of 3 over 3. So the final answer is the negative of 2 times square root of 3 over 3. Okay, for problem 8, we have the cotangent of negative 840 degrees. So once again, I've got to get my coterminal angle between 0 degrees and 360 degrees. So we have negative 840 degrees. Let me add to this. We'll need to go 360 degrees times 3, which is 1080 degrees. If you find that sum, you're going to have 240 degrees. So that's the coterminal angle I want to work with. So let's say that the cotangent of negative 840 degrees is equal to the cotangent of 240 degrees. And then again, I'm going to think about my reference angle here. I'm going to be in quadrant 3. So once again, your theta prime is going to be that angle, so 240 degrees, minus, again, you got to take that straight angle away, so the 180 degrees. So this is going to be 60 degrees. Okay, so that's my reference angle. So thinking about cotangent in quadrant 3, it's positive. So I don't have to make any sign adjustments here because everything here is from quadrant 1, so they're all positive. So in this case, I can just take the value of the cotangent of 60 degrees. I don't have to make any adjustments to the sign. So the cotangent of 60 degrees is the square root of 3. Let me make the 3 better. And this will be over 3. So that's going to be my answer, the square root of 3 over 3. All right, for problem number 9, we are given cosine squared of 60 degrees plus secant squared of 150 degrees minus cosecant squared of 210 degrees. So for this problem, we're just going to plug in. Okay, that's all it is. It's not that complicated. Where a lot of students get lost, remember this notation. If you see secant squared theta, this is the same thing as secant of theta squared like this. Okay, this is just how we write it. It's a notational thing. It's just something you have to get used to with trigonometry. So what I'm going to start off with is just finding these values in here in terms of these angles. You need to put this in terms of something you can get from this table. So 60 degrees, you're good to go. You don't have to worry about that. For 150 degrees, you need to think about the reference angle. So the reference angle, if you're in quadrant 2 with a 150 degree angle, it's going to be 180 degrees minus 150 degrees. So it's 30 degrees. Okay, so let me write here that theta prime for this guy is 30 degrees. Okay, we're just going to keep that off to the side. And then for this guy, if it's 210 degrees, well, your theta prime there, I'm in quadrant 3, it's 210 degrees minus 180 degrees, which is going to be 30 degrees as well. So this is going to be my theta prime here, which is 30 degrees. Okay, so I'm just going to make a little replacement here. Let me come down here just a little bit. So first I'm going to write my cosine squared of 60 degrees. I'm not going to do anything with that yet. Then for this one, I need to figure out what this is going to be. So again, I'm using a 30-degree reference angle. 150 degrees is going to be in quadrant 2, and secant is going to be negative in quadrants 2 and 3. Okay, so I want the negative of the secant of 30 degrees. That's what I'm going to use. And again, because of this notation, what I'm going to do is write it like this, and I'm just going to wrap it and square it like this, and I'll just put a plus here. Okay, so this is the notation I'll use just so that it's not confusing for anyone. Now for this one, cosecant, if you think about that, it's going to be negative in this quadrant 3, right? So cosecant is negative in quadrants 3 and 4. So you have to be really careful here. Let me put a minus here, and I'm not going to mess with that. And then I'm going to wrap this, and I'm going to say that this is the negative of the cosecant of this 30-degree angle. So this 30-degree angle. And let me close that down, and let me square this like this. So let me put that this is equal to this. And we're going to come down here so we have some room. So let's start with the cosine of 60 degrees. And maybe I should rewrite this so it's more clear. So the cosine of 60 degrees like this, and then we're going to square that, okay? So first find the cosine of 60 degrees. So looking at this guy, here's 60 degrees, here's cosine, so we have 1/2. Okay, so the cosine of 60 degrees is 1/2. So you would have 1/2 squared. Then plus, for this guy, find the secant of 30 degrees. So where's my secant? It's going to be right here. So the secant of 30 degrees is 2 times square root of 3 over 3. So let me put the negative of 2 times square root of 3 over 3. And this is going to be wrapped and squared. Then minus over here, you have your negative of the cosecant of 30 degrees. So first let me put the negative out here. The cosecant of 30 degrees. So cosecant of 30 degrees is 2. So that's a negative 2. And this is going to be squared. Okay, let me put my equals here. And we don't need the table anymore. We can just crank this out. So 1/2 squared is 1/4. And then for this guy, the negative is going to go away. 2 squared is going to be 4. The square root of 3 squared is going to be 3. And then down here, 3 squared is going to be 9. So remember with something like this, it's basically like you had negative 1 squared, and then times 2 squared, and then times the square root of 3 being squared. This exponent here is being applied to everything in there over this 3 squared. So that's where I got this from if you're confused. Negative 1 squared is 1, so I don't write it. 2 squared is 4. Square root of 3 squared is 3, and 3 squared is 9. So that's where this is coming from. Let me get rid of this. And you can cancel a common factor of 3 between numerator and denominator. So this is going to be 4/3. So this is 4/3. And then minus the negative 2 being squared. Again, this is wrapped in parentheses. So both the negative and the 2 are squared. So that's positive 4. Now what I would do is get a common denominator here. So that's going to be 12. So let me multiply this by 3 over 3. Let me multiply this by 4 over 4. Let me multiply this, let me scooch this down, by 12 over 12. So at the end of the day, this is going to give me 3 over 12 plus 16 over 12 minus 48 over 12, which is equal to 3 plus 16, which is 19, minus 48, which is negative 29, over your common denominator of 12. All right, let's take a look at problem number 10 now. So here we have 2 times tangent squared of 120 degrees plus 3 times sine squared of 150 degrees minus cosine squared of 180 degrees. Okay, what I would do here is figure out the reference angle for these two. For this one, we're going to have to work on that on a little sketch. I'll show you that in a moment. So if I think about 2 times tangent squared of 120 degrees, well, think about the reference angle for 120 degrees. You're in quadrant 2, so your reference angle is going to be 180 degrees minus 120 degrees, so that's 60 degrees. Now, if I think about in quadrant 2, tangent is going to be negative, right? It's negative in quadrants 2 and 4. So I'm going to say, wrap this in parentheses, the negative of your tangent of 60 degrees, close this down, and I'm going to square this. Okay, so I'm just converting the notation over to something that is a little bit easier. And actually, I don't think this is all going to fit if I write it this wide. So let me put 2 times the negative tangent of this 60 degrees, and this is going to be squared. So let me get rid of this. And let me slide this up here. Okay, so the next part, you have 150 degrees. So again, I'm in quadrant 2. So my reference angle, you have 180 degrees minus 150 degrees. That's going to be 30 degrees. Now, sine is going to be positive in quadrant 2. So you don't need to make a sign adjustment there. You can just put plus your 3 times, let me wrap this, so the sine of your 30 degrees, and then we're going to square that. Then we have minus. Now this one, if you think about the cosine of 180 degrees, at this point we haven't talked about that yet. So what you'll need to do is make yourself a little sketch. This is something we will cover when we get to the unit circle, but we're not quite there yet. So we make a sketch. We know 180 degrees is a straight angle. So you could pick a point on the terminal side here. Let's just say I pick this one, which is what everyone would pick. Easy to work with. So the x value is -1, the y value is 0. Okay, so let me write that x is -1 and y is 0. And you can pick anything you want on this terminal side. You could have picked -6, 0. You could have picked -2,000,000, 0. It will work out the same. So we need to figure out what is the r value. So r is equal to the square root of x squared plus y squared. Remember, when we think about r, it's the distance from the point, which in this case is -1, 0, to your origin. So if we think about that distance, we should get 1 unit, right? Because it's 1 unit away from the origin. So let's plug in and see if we get that. So we have r is equal to the square root of if I square x, let me plug this into Newton's law, so negative 1 being squared, then plus, if I square y, well, y is 0, 0 squared is 0, so you can actually get rid of this. Negative 1 being squared would be done first, that's positive 1, and then the square root of positive 1 is going to be 1. So we get r is equal to 1. Okay, so now that we have these guys, we can just plug in. We know that the cosine of theta is equal to x over r. Well, here we have the cosine of 180 degrees, and so x is negative 1 and r is 1, so this is negative 1. So coming back up, I would want the cosine of 180 degrees, and that guy's going to be squared. Now we know, I'm just going to write this off to the side, that the cosine of 180 degrees is equal to negative 1. We will plug that in a moment. So let me put equals here, and let me come down here, and let me put equals here, and let me slide down just a little bit. So the first one is the tangent of 60 degrees. So the tangent of 60 degrees is the square root of 3. So we would have 2 times, wrap this in parentheses, the negative of the square root of 3, and this is squared. Then plus, you have 3 times, your sine of 30 degrees is going to be a half, and then this is going to be squared, and then minus, remember we just said that the cosine of 180 degrees is negative 1, so let me wrap this and put negative 1 being squared like this. So now we have the negative of the square root of 3 squared. So if I square negative 1, it's going to go away, right? It's positive 1. The square root of 3 being squared is 3. So this is 2 times 3, or 6, plus this 1/2 would be squared first, so that's a fourth. 3 times a fourth is just 3/4. And then you have negative 1 being squared first. Okay, so that's positive 1, and then you're just going to subtract that away. So what I'm going to do here is get a common denominator going, and my LCD is going to be 4. So this is 6 times 4 over 4, plus 3/4, don't need to do anything there, minus 1 times 4 over 4. So this equals 24 plus 3 minus 4 over the common denominator of 4, which is going to be equal to 24 plus 3 is 27, and 27 minus 4 is 23, so this is 23 over 4. All right, let's take a look at our practice test. We want to use a calculator to find each. We're going to round to the nearest 10,000th. So looking at the first problem, we have the cosecant of negative 560 degrees. So for a lot of you, you're using an online calculator, so you can just type this in directly and it's not an issue. But for others, you're using some sort of calculator and there's no cosecant button. So in that particular case, you need to use your reciprocal identity, where basically you say that the cosecant of theta is equal to 1 over your sine of theta. And for this one, I would say this is equal to 1 over your sine of negative 560 degrees like this. So I would start by just hitting the 1 on the calculator, the divided by key, then the sine key, and then basically you have parentheses that open up. Just type in negative 560. You don't need the degree symbol. Your degree mode should be on. You can check that really quickly by doing sine of 90 and you get 1, so you know you're in degree mode. So once you've typed that in, just close the parentheses, or sometimes it does it for you, and just hit enter. So this is going to give us approximately here 2.92, and then let me go 380, and my calculator stops after 44. Your calculator may give more digits. But again, we are going to round this to the nearest 10,000th. So in case you don't know, this is the tenths, hundredths, thousandths, and this is the 10,000ths, okay? So we want to round to that. So we would look at the digit that follows. So in this case, that's a 0. So that tells me that this 8 is going to stay unchanged. And I can just delete all of these, right? They won't add any value to the number if I change them into a 0, so you can just get rid of them. So the approximate answer here is 2.9238. Okay, let's look at problem 2. So now we have the sine of 230 degrees. So in this particular case, this problem is interesting because we have a negative value, and sometimes students will have trouble rounding when there's a negative. So let me show you what to do here. So first and foremost, you know that this is a negative answer because 230 degrees is in quadrant 3, and sine is negative in quadrants 3 and 4. So if we punch this into the calculator by hitting the sine key and then followed by the 230, and then again, you might have to close your parentheses, you're going to get approximately, I'm going to put negative 0.766. Let's go 0, and then I've got 4, 4, 4, 4, and then 3, 1, and that's where my calculator stops. Again, yours may give a different number of digits or change some things at the end. It's just based on how your calculator works. But we want to round this guy. So basically, I'm going to the nearest 10,000th. So tenths, hundredths, thousandths. This is the 10,000ths place. What I would do is pretend that this is just a positive number and forget about the fact that it's negative, because people get confused when you start talking about rounding up or rounding down. So I just look at this digit that follows here. So if this is a 4 or less, then this digit stays unchanged, right? So I don't have to do anything here. And then basically, because we're working with a decimal number here, if I change all of these numbers that follow into a 0, they don't add any value, so you can just get rid of them. So I'm basically going to cut all this off. This 0 here wouldn't add any value, so you can cut that off. So the answer here is just negative 0.766. So if you're rounding with a negative, just use your normal procedure. Don't worry about the fact that it's negative. You can just think about it in terms of its absolute value, use your procedure and round, and then just consider the negative after. Okay, let's look at problem 3. So here we have the secant of 200 degrees. And again, you might not have a secant key. So the secant of theta, again, is equal to 1 over your cosine of theta. So you might have to say this is 1 over the cosine of 200 degrees, just to punch it into your calculator. So you hit the 1 key, the divided by key, the cosine key, in the parentheses type in 200, and just hit enter. And so this is approximately going to be negative, we have 1.064, and then I'll go 1777772, and that's where my calculator stops. We know that cosine would be negative and also secant would be negative in quadrants 2 and 3. A 200-degree angle is going to be in quadrant 3, right? So we know it's going to be negative with the cosine value or the secant value. Now, in this particular case, we have a negative again. So this is where people get tripped up on rounding. Just again, pretend like this is positive. Don't even consider the negative. You're just going to go through and find the 10,000ths place. So tenths, hundredths, thousandths, 10,000ths. So right there. And just look at the digit that follows. So right here, this is going to be a 7. So that means I add 1 to this digit. 1 plus 1 is 2. So this becomes a 2 here. And again, you could just cut off all these digits, because what happens is they turn into a 0, and then the zeros don't add any value, so you can just delete them. So the answer here is about, or you could say approximately, negative 1.0642. All right, for problem 4, we have the cosecant of negative 550 degrees. And again, you might not have that button on your calculator. So let's say the cosecant of theta is equal to 1 over your sine of theta. So this is equal to 1 over your sine of negative 550 degrees. Now this guy is going to actually be positive. If you added 720 degrees to this angle measure, you would get a 170-degree coterminal angle. So that's in quadrant 2. And sine and also cosecant, they're going to be positive in quadrants 1 and 2. So let's say this is approximately, I'll say 5.758770483. And again, we're rounding to the nearest 10,000th. So tenths, hundredths, thousandths, and then 10,000ths. So right there. And again, the digit that follows is a 7. So that means I'm going to add 1 to this digit right here. So 7 plus 1 is 8. And once again, you can just delete all these digits that follow. So this is going to be approximately 5.7588. All right, for the next few problems, we want to find the exact value. And for problem number 5, we have the inverse sine of, you have your negative of the square root of 2 over 2. Now, this is very straightforward to just punch into the calculator, but the answer might be very confusing for you. So if you punch this into your calculator using your inverse sine key, or some calculators will write it as arc sine like this. Again, it just depends on your calculator. Well, essentially what's going to happen is you're going to get negative 45 degrees. So let me stop for a moment. If you understand where this comes from, then just move on. But if you don't, let me explain what's going on here. When we think about the sine of theta, so the sine of theta, remember this is the opposite over the hypotenuse. So if I hit the sine key followed by an angle measure, then I'm going to get this ratio here, right? My calculator will spit that out. If I go over and say the inverse sine of this opposite over hypotenuse, well, that's going to give me the angle measure back. But the problem is, when we think about the sine function in general, if you looked at y equals sine of x on an online graphing calculator like Desmos or something like that, you're going to see that it's not a one-to-one function. Remember, for a one-to-one function, for each x there's one y, and for each y there's one x. Well, y equals sine of x is not a one-to-one function. It fails the horizontal line test. So what ends up happening is we have to restrict the domain of our sine function in order to get an inverse. And we're going to talk more about this later on, but essentially what's going to happen is if you get a positive answer from this guy, you're going to be in quadrant 1, and if you get a negative answer, you're going to be in quadrant 4, and you're going to rotate clockwise. But for right now, if you get an answer of negative 45 degrees, you have to do a little bit of thinking there. Okay, so I'm in quadrant 4. The coterminal angle would be me adding 360 degrees to negative 45 degrees, so that's 315 degrees. Now, if I sat here and said that the sine of, let's say, theta was equal to the negative of the square root of 2 over 2, and you said that theta was negative 45 degrees, you would be only partially correct, right? There's an infinite number of angles whose sine value is going to be negative square root of 2 over 2, okay? This is just something we can use to say that, okay, well, I know sine is going to be negative in quadrants 3 or 4. And then I can just say that, well, I would want to have a 45-degree reference angle, so theta could be 315 degrees, right? That's in quadrant 4, it has a 45-degree reference angle. Or it could also be 225 degrees. Again, that's in quadrant 3, and it has a 45-degree reference angle, and then you can find an infinite number of coterminal angles with those two angles to produce a sine value that's going to be the negative of the square root of 2 over 2. So again, I don't want to go too far into this because we're going to talk about it later on in the course, but I know a lot of students at this point get very confused when they get an answer of negative 45 degrees. All right, let's take a look at problem number 6 now. So we have the inverse tangent of the square root of 3 over 3. So this is fairly straightforward. You could just punch this into your calculator. You're going to get an answer of 30 degrees exactly. But again, if you're thinking about this in terms of, let's say I had tangent of theta was equal to the square root of 3 over 3, and I wanted to figure out, well, what is theta? Well, there's an infinite number of angles where you take the tangent of it and you get the square root of 3 over 3. This right here, this 30 degrees, you just think about that as your reference angle. So tangent is going to be positive in quadrants 1 or 3. So any angle that's 30 degrees or coterminal with 30 degrees is going to have a tangent value that's square root of 3 over 3. So for example, 390 degrees, right? The tangent of 390 degrees would also be the square root of 3 over 3. But additionally, if you think about in quadrant 3, your tangent value is also going to be positive. So you could say in quadrant 3, a 210 degree angle would have a 30 degree reference angle. So the tangent of 210 degrees or the tangent of any angle that's coterminal with 210 degrees would also give you the square root of 3 over 3. So just something to keep in mind for later on in the course. All right, for the next few problems, we want to use a calculator to find theta. We want to, again, round to the nearest 10,000th. So for problem 7, we're going to find theta such that it's greater than or equal to 0 degrees and less than or equal to 90 degrees. So we're told that the sine of theta is equal to 1/9. And again, the reason we have this restriction here is because when we think about this, there's going to be an infinite number of angles whose sine value is going to be 1/9. Okay, so that's why that restriction is there. So we know already that the sine of theta is equal to the opposite over the hypotenuse. And so again, the sine inverse of your opposite over your hypotenuse, or again, you could say the arc sine if you call it that, this is going to be equal to your angle theta. Okay, so we're just going to punch this into the calculator. We're going to say that theta is equal to the sine inverse of your 1/9. So that's your ratio there. That's the opposite over the hypotenuse. And this is going to be approximately, I get 6.379370208, and that's where my calculator stops. Again, I'm going to go to the nearest 10,000th. So tenths, hundredths, thousandths, 10,000ths. So right there, the digit that follows is a 7. So I'm going to add 1 to this. So 3 plus 1 is 4. And I can get rid of all of these. And this answer is in terms of degrees. So the angle that we're looking for, this theta, is going to be approximately 6.3794 degrees. And again, just so this is clear, there's an infinite number of angles whose sine value is going to be 1/9. Okay, let's look at problem 8. So again, theta will be greater than or equal to 0 degrees and less than or equal to 90 degrees. So we have the cosine of theta is equal to 8 over 13. So again, the cosine of theta is equal to your adjacent over your hypotenuse. And so your inverse cosine of your adjacent over your hypotenuse will be equal to, let me make that y better, your theta. So in this case, I can say theta is equal to your inverse cosine of this 8 over 13. That's your adjacent over your hypotenuse. So this is approximately, let's say 52.02012756. That's where my calculator stops. So let's go to the 10,000ths place. So that's going to be right here. So you can see that the digit that follows is a 2, so that 1 would stay unchanged, and we get rid of all this. And again, this is in terms of degrees. So my angle theta is going to be approximately 52.0201 degrees. Okay, let's look at problem number 9. So again, theta is greater than or equal to 0 degrees and less than or equal to 90 degrees. So we have the cosecant of theta is equal to 16 over 11. So once again, you might not have an inverse cosecant key. So we would say the cosecant of theta is equal to, again, 1 over the sine of theta. So all you have to do to find the sine of theta is just flip this, right? So the sine of theta is equal to 11 over 16. So we would say that theta is equal to my inverse sine of 11 over 16. So this is approximately going to be, let's go 43.43253656. That's where my calculator stops. So I'm going to round to the nearest 10,000th. So tenths, hundredths, thousandths. This is the 10,000ths. So I'm looking at that digit that follows. This is a 3. So this 5 stays unchanged, and all of this gets cut off. So this is in terms of degrees. So your theta is approximately 43.4325 degrees. Okay, let's look at problem 10. So theta is greater than or equal to 0 degrees and less than or equal to 90 degrees. And we're given that the secant of theta is equal to 17 over 5. So again, we know that the secant of theta is equal to 1 over the cosine of theta. So my cosine of theta here is going to be, just flip this, so this is 5 over 17. Again, you can just find the reciprocal. I can say that theta is equal to the inverse cosine of this 5 over 17, and this is approximately 72, let's say 0.89536. Let's go 482, that's where my calculator stops. So again, I want to round to the nearest 10,000th. So tenths, hundredths, thousandths. This is going to be the 10,000ths right there. So the digit that follows is going to be a 6. So I'm going to add 1 to that 3. That's going to give me 4, and then cut everything else off. So this is in terms of degrees. So theta is approximately 72.895 degrees. All right, let's take a look at the practice test. So here we want to solve each triangle. And what that means, we're going to find all the missing angle measures, and we're also going to find all the missing side lengths. For the answers we're going to present, we're going to round to the nearest 10th. And let's take a look at the first problem. So we have this triangle here. I think probably the easiest thing to do is to find the missing angle measure, which is the measure of this angle A. And to do this, remember, this is a 90-degree angle here. So if you think about the sum of the measures of all of the angles in your triangle is 180 degrees. So you could say that the measure of your angle A is equal to 180 degrees minus 90 degrees, and then minus your 62 degrees. That's one way to do it. But again, if you know this one's 90 degrees, well then this one and this one, those are going to be complementary angles, meaning the sum would be 90 degrees. So you can get rid of this part here. It's really not needed. I'll just drag this up here and say that the measure of angle A is equal to 90 degrees minus 62 degrees. So that's going to be equal to 28 degrees. So I'll just write this in here as 28 degrees. Let me actually erase the scratch work and put the measure of angle A as 28 degrees. Okay, now the more tedious process is to find the missing side lengths. So you're missing this guy right here and this guy right here. And the way we set this up, if this is my angle A, capital letter A, then the side opposite would be named with a lowercase a. That's just what we typically do. And then this guy right here, this angle is the right angle. So we're denoting that with a capital C. So the side opposite is going to be your hypotenuse, your longest side. So we typically use a lowercase c for that. So if I want to find the length of this side A, well, what can I do? I know the measure of this angle B is 62 degrees. And let's think about the fact that we do have the side opposite of that. So that's going to be 8. So the way I could set this up, I could say that the sine of this 62-degree angle is equal to, again, the opposite. Let me just write this out so nobody's lost. So the opposite over the hypotenuse. So for the opposite, I could just plug in an 8. And then for the hypotenuse, I can just plug in a c. So there's lots of quick ways to solve this, but I'm going to do this in a slower way so nobody's lost because I want c by itself. Okay, so I think a lot of people would be confused if I did this in a quicker way. So what I'm going to first do is multiply both sides by c. So I'm going to do this over here so that this would cancel. And so now you have c times the sine of 62 degrees is equal to 8. And so what I'm going to do now is divide both sides by the sine of 62 degrees. So we would have c is equal to 8 divided by the sine of 62 degrees. So I'm just doing that in multiple steps so that nobody is lost. Let's drag this up here like that. And this is something you could just punch into your calculator. Remember, we're going to round to the nearest tenth. So if I punch that into my calculator, I get approximately, let's say 9.0605. And I'm just going to stop there. We're going to the nearest tenth. So I'm going to look at this digit right here. The 6 falls in the category of 5 or greater. So I'm going to take this 0 and add 1 to it and cut everything else off. So I'll say the length for C is approximately 9.1. We don't have any units here, so I'm just going to put C is approximately 9.1. And then I can erase this and just put 9.1 in there. And then I need to figure out what is the length for this A here, right? That side. So for this one, what I would do is actually use my tangent. I always try to use the information given. It's just going to make your answer a little bit more accurate. If you use this guy right here, it's an approximation. So what I would say is that I'm going to involve this angle again, and I'm going to think about this, which is the opposite, and then this guy right here, which is your adjacent. So let's say that the tangent of this angle, which is 62 degrees, is equal to, again, this is the opposite over the adjacent. So the opposite here is 8, and the adjacent here is going to be this lowercase a. So that's my side length. And again, let me do this in multiple steps so nobody's lost. I'm going to multiply both sides by a. Let me show that over there. So this would cancel. So you get a times the tangent of 62 degrees is equal to 8. Let me get rid of this so I can save some space here. And then essentially I'm just going to divide both sides of the equation by tangent of 62 degrees. So we'll say that a is equal to 8 divided by the tangent of this 62 degrees. Let me get rid of this. And I'm going to put approximately here. Let's just key this into the calculator. And what I get is about, let me go 4.2536. I think that's where I can just stop. We're rounding to the nearest tenth. So I'm going to look at this 5 here. That falls in the category of 5 or greater. So I'm going to add 1 to that too. So I'll make this 4.3 and just cut everything else off. So let's say that A is approximately 4.3. And then we'll get rid of this and we'll just write that in. So this is going to be about 4.3. Okay, let's take a look at problem number 2. Again, the quickest thing I can do is to figure out the measure of this angle A. This is missing here. So I know that this one is 90 degrees. And so again, this angle B plus this angle A, in terms of those measures, those guys are complementary angles. So the measures will sum to 90 degrees. So I can say that the measure of angle A is equal to 90 degrees minus this given angle measure, which is 58.4 degrees. So that's going to be 31.6 degrees. So let me write that in. So 31.6 degrees. Okay, so we've got that guy. So now let's go into the more tedious task, which is to figure out the missing side lengths. So again, opposite of this angle B, we're going to call this lowercase b. And then opposite of this angle A, we're going to call this lowercase a. Opposite of this angle C, which is your right angle, your 90-degree angle, this is given, this is 16, that's your hypotenuse. So for the side length A, if you wanted to, you could use this guy. It's not an approximation, so you won't have an issue there. I will go ahead and say that the sine of this 31.6 degrees, this is equal to your opposite over your hypotenuse. So let me write this out so nobody's lost. So this is the opposite over the hypotenuse. And in this case, your opposite is A, and your hypotenuse is given as 16. So let me actually get rid of this and drag this up here. And all I'm going to do is just multiply both sides by 16. Let me make that A better. And so I'll have this over here. Okay, so this would cancel, and you have 16 times the sine of 31.6 degrees is going to be equal to A. So let me write that like that, and let me clear this out from here. All right. So the next thing I would do here is just punch this into my calculator, and I'm going to get that A is approximately, so I'll go 8.38377, and I'll just stop there. Let me erase this from here. And we want to round to the nearest tenth, so I'm going to go to right here. So this 8 here falls in the category of 5 or greater, so add 1 to the 3. So this becomes 8.4. Again, you can cut everything off after the 4. So my A, that missing side length, is about, or you could say approximately, 8.4. All right, so now I need to figure out this lowercase b here, this missing side length. So for that one, you could use this angle here if you want. There's a lot of different possibilities. So I can say the sine of this angle B is going to be this lowercase b, which is the opposite, over the hypotenuse, which is 16. So let's say that the sine of 58.4 degrees is equal to, again, the opposite is going to be this lowercase b, and the hypotenuse is going to be 16. So all I would need to do is multiply both sides by 16. So let's say that we have b is equal to 16 times the sine of 58.4 degrees. Let me get rid of this. And let's punch this into the calculator. And so I'll say that b is approximately 13.6276, and I'll just stop there. Let me get rid of this for right now. So to round to the nearest tenth, I'm going to go to this 6 here. The digit that follows is a 2, so that falls in the category of 4 or less. So let's cut these off, and we'll leave the 6 unchanged. So let's just erase this and put that this side here is approximately 13.6. All right, for problem 3, now we have this triangle here. And once again, I'm going to start out by finding the missing angle measure. So let's notate that this is 90 degrees. I think everybody knows that, but just for clarity. And then the sum of the measure of this angle A plus the measure of this angle B is 90 degrees. Remember, those are complementary angles. So we'll say that the measure of this angle B is going to be equal to 90 degrees minus this 24 degrees here, which is going to give me 66 degrees. So we can write this in. So 66 degrees like that. Let me get rid of the scratch work and just put that the measure of angle B is 66 degrees. All right, now we need to figure out the 2 missing side lengths. So opposite of this angle B, we're going to use a lowercase b, and then opposite of this angle A, we're going to use a lowercase a. So lots of different ways you can approach this. These 2 angle measures that we have here, the 24 degrees and the 66 degrees, those are not approximations, so you can use either angle if you want. So let's just go ahead and say that we want the sine of this angle B, which is 66 degrees. This is your opposite over your hypotenuse. And in this case, the opposite is this side B. And the hypotenuse, again, this is across from the right angle. So this is 7. And what you could do here, let me get rid of this scratch work. You could just multiply both sides by 7 so that you can clear that denominator. So this is going to go away. And you could say that B is equal to 7 times the sine of 66 degrees. So let's punch that into the calculator. And I would say that B is approximately, I'm going to write down 6.39481. And I can just stop there. We're going to round to the nearest tenth. So looking at the 9 that's in the hundredths place, that falls in the category of 5 or greater. So I'm going to add 1 to this 3 and cut everything else off. So B would be approximately 6.4. Let me get rid of this and just put 6.4 like that. And I'll get rid of all this scratch work. So the other guy we need to figure out is this A here. So again, you can use this angle or this angle, whatever you want to do. I think it's probably easier just to use this angle here and say that the sine of 24 degrees is going to be equal to, so this A over, again, the hypotenuse is 7. So multiply both sides by 7, and you would get that A is equal to 7 times the sine of 24 degrees. Let me get rid of this. I'll just put A is approximately here. Let's key this into the calculator, and I get about 2.84715. Let's just stop there. We're rounding to the nearest tenth, so I'm going to look at this 4 here. That falls in the category of 4 or less, so you can just delete these guys and get rid of this. So we'll go ahead and say that this guy right here is approximately 2.8. All right, let's take a look at problem number 4. So now we're switching things up a little bit. We have these 2 sides that are given, and we're missing this side length over here. And then we don't know the measure of this angle B or this measure for angle A. Now, thinking about this, I know that this guy right here, this side labeled with a length 14, that's my hypotenuse. That's my C in most cases if you want to label it. And then my side opposite of this angle B that has length 10. Now, if I wanted to figure out this side right here, let's just call it lowercase a, since it's opposite of this angle A, well, you could use your Pythagorean theorem. So a squared, this guy right here, which is a leg, plus b squared, which is going to be this guy right here, which is the other leg, is equal to c squared, which is your hypotenuse being squared. So we don't know what a is, so I'll just write a squared again. Then plus, we know what b is, it's 10. 10 squared is 100. And then we know what c is, that's a hypotenuse. That's going to be 14. 14 squared is 196. So for this one, you would have a squared is equal to, if I subtract 100 away from each side of the equation, this would cancel. 196 minus 100 is 96. If you use your square root property here, well then a would be equal to plus or minus the square root of 96. Now, because we're talking about a length here, you don't want the negative square root, you just want the principal one. And of course, you could estimate this because 96 is not a perfect square, or you could break it down and you could say that 96 is 16 times 6, and of course 16 is a perfect square, so this could be 4 times the square root of 6 if you wanted to write it like this. But in this particular case, I prefer to estimate it. So I'm just going to key it into my calculator. And if I round it to the nearest tenth, I get about 9.8. So I'm going to say that A is approximately 9.8. Again, if you want to use that exact value of 4 times square root of 6, that's up to you. So let me put that this is 9.8. So now we need to work on these two angle measures here. And for this, we're going to end up using our inverse trigonometric functions that we talked about in the last lesson. So let's think about how I could figure out the measure of this angle B here. Well, I can take and say that the sine of this angle B is equal to the opposite over the hypotenuse. Now I know my opposite is 10 and my hypotenuse is 14. So I can put in 10 over 14 here. And you could simplify that if you wanted to. You're plugging it into a calculator, so I don't know if you're wasting time with that. But let's just do it for completeness. Let's just say this is 5 over 7, like this. And then essentially what's going to happen from here is you would say that B is going to be equal to the inverse sine of this guy right here. You're plugging in the 5 over 7. So this is something you can key into your calculator. And again, when you talk about the inverse sine function, it's going to give you, if this guy is positive, something in quadrant 1, okay, which is exactly what we want. We want an acute angle here. And again, we'll go into more detail in terms of how the inverse sine function works later on in the course when we talk about solving trigonometric equations. So for right now, let's just key this into the calculator. And so I'll say that the measure of this angle B is approximately, let's go 45 point, rounding to the nearest tenth, I'll say this is a 6 here, and this is in terms of degrees. So I get about 45.6 degrees. So let's put that in there. And then I need my measure for my angle A. So again, I'm going to try to use this guy and this guy because this was an estimate, just to be more accurate. So in terms of this guy right here, this is your adjacent, if you think about this in terms of your angle A. So this is your adjacent side, and this is your hypotenuse. So you can use your cosine function. So cosine of this angle A is equal to, again, your adjacent is 10, your hypotenuse is 14. You could simplify that and say that this is 5 over 7. So this is 5 over 7. And remember, the cosine of this angle here, A, is equal to the sine of this angle B here, right? We learned that in a previous lesson. So it should be no surprise that this is 5/7. But we're going to get a different answer if we use our inverse cosine function. So we're going to plug in this 5/7 here, and that's going to be the measure for our angle A. So we'll say that A is equal to that. So let's punch that into the calculator. And I'll say that I get about 44.4 degrees. Again, if I'm rounding to the nearest tenth. So the measure of angle A is approximately 44.4 degrees. So let's put this in here and say this is 44.4 degrees. Now the thing that I would check here is just to make sure that this guy plus this guy is giving you 90 degrees. And in this case it does. So we're basically good to go. Okay, let's take a look at problem number 5. So again, we're given these two side lengths. And I would start by figuring out what is the length of the side opposite of this angle A. I'll just call that lowercase a. And I'm just going to use my Pythagorean theorem again. So a squared plus your b, in this case, is the side opposite of this angle b. So let's say that's 3 squared or 9 is equal to your c squared. So c here is the length of the hypotenuse, or again, the side opposite of your 90-degree angle. So that's going to be 9.2 being squared. Let me wrap this for clarity so nobody gets lost there. So this is going to be a squared plus 9 is equal to, if I square 9.2, I get 84.64. And I'm just going to subtract 9 away from each side of the equation. This would cancel. You'll have a squared is equal to 84.64 minus 9. That's going to give me 75.64. Let me slide this up right here. And I'll say that a is equal to plus or minus the square root of 75.64. A is the length of this side here, so we don't need a negative square root. You can throw that away. This is something you're definitely going to want to approximate. So I'll just say that a is approximately, let's go 8.7 if we're rounding to the nearest tenth. So 8.7. Let me get rid of this, and I'll just write that here. So this is about 8.7. So now we need to figure out the measure of this angle A and the measure of this angle B. So thinking about the measure of angle A, well, what do I have? I have my adjacent and I have my hypotenuse. So we'll say that the cosine of A is equal to adjacent over hypotenuse, which in this particular case, the adjacent is 3 and the hypotenuse is 9.2. So what I would do here is say that the measure of your angle A is the inverse cosine. So the inverse cosine of this guy right here, so 3 over 9.2. So let's key that into the calculator. And what I get is the measure of angle A is about, I'm just going to write what my calculator gives me. So 70 point, we have 9685. Now this one is a little bit tricky to round, that's why I wrote it out. If you think about the digit in the tenths place, it's going to be this 9. So you look at the digit that follows, so in this case that's a 6. So that tells me I want to add 1 to this 9. But again, in this case, 9 plus 1 is 10. So what you actually have to do is get rid of this and put this as a 0. And you're going to add 1 to this, the digit in the ones place. So this becomes 71, or you could say 71 degrees. All right, so that's an approximation. I'm just going to write 71 degrees in here. Now for the measure of angle B, what you could do is use the sine, because you're going to have your opposite over your hypotenuse. And again, the sine of B is equal to the cosine of A. So I could just say that the inverse sine of my opposite, which is 3, over my hypotenuse, which is 9.2, that's going to be equal to my angle B. So key this into the calculator, and I'll say that the measure of angle B is approximately 19 degrees. So let me get rid of this, and let's put 19 degrees here like this. And again, 19 degrees plus 71 degrees would give you 90 degrees, so this is good to go. Okay, let's take a look at problem number 6 now. So in this case, I would start out by finding this missing side length here. So this is opposite of this angle B. So let's use a lowercase b to denote this side. And what we'll do is use our Pythagorean theorem. So I'll go ahead and say that 7 squared plus this guy, which is b squared, is going to be equal to the length of the hypotenuse is 8.9. And we're going to want to square that. I'm just going to wrap this for clarity so nobody gets confused. This is something I'm just going to punch into my calculator. So 7 squared we know is 49. So let's say this is b squared plus 49 is equal to 8.9 being squared. That's going to give me 79.21. What I'll do is say b squared is equal to, I'm going to subtract 49 away from each side of the equation. Let me slide this down and show this so nobody is lost. So this guy is going to cancel. And so 79.21 minus 49, that's going to give me 30.21. Okay, so using the square root property, b would be equal to plus or minus the square root of 30.21. But again, we don't want the negative square root. So we'll just say the principal square root of 30.21. So what I'll do here is just key this into my calculator. And if I'm rounding to the nearest tenth, I'm going to get 5.5. So let me erase all of this. And we'll just say that b is approximately 5.5. And let's put that down here. Okay, so I'm missing the measure of my angle A and the measure of my angle B. So if you think about your angle A and you think about, well, I have this guy that was given and this guy that was given. So this is opposite, which is 7, and this is your hypotenuse, which is 8.9. So you can say that the sine of this angle A is equal to, again, your opposite is 7, and your hypotenuse is 8.9. So if you want to find out the measure of your angle A, again, you can just use your inverse sine function. So you'll say that A is equal to the inverse sine of this guy right here, so 7 over 8.9. Let's key that into the calculator. And if I round to the nearest tenth, I get 51.9. So let's say that this is 51.9 degrees. So this is 51.9 degrees. Let me get rid of this. And I'll just say that the measure of this angle A is about 51.9 degrees. Now, for this one, again, you could just go 90 degrees minus 51.9 degrees if you wanted to, and that's going to give you 38.1 degrees. But let's see if we can get a little bit more practice and do it a different way. So again, I'm going to use this guy and this guy. I don't want to use what I estimated because, again, you can get some errors doing that. So if I think about in relation to this angle B, we have this guy, which is going to be the adjacent, and I have this guy right here, which is my hypotenuse. So if I use the cosine of B, this is going to be my adjacent, which is 7, over my hypotenuse, which is 8.9. So again, the cosine of B is exactly equal to the sine of A. And this is something we learned in a previous lesson and we've talked about earlier today. So all I have to do to find B is say that it's the inverse cosine of this 7 over 8.9. So let's key this into the calculator. And if I round to the nearest tenth, I do get that 38.1 degrees that I was looking for. So this would be 38.1 degrees. And let's just write that the measure of this angle B is going to be about 38.1 degrees. And one thing I would do is just always check that the sum of the measures of all these angles is 180 degrees, or just sum these two and make sure it's 90 degrees. In this case, it is. All right, let's take a look at problem number 7. So now we're trying to find these two sides here in terms of the length and the missing angle measure here. Let's start off with the measure of this angle A. So we know that the measure of angle A plus the measure of angle B is going to be 90 degrees. So this is just going to be 90 degrees minus this 50 degrees, which would be 40 degrees. So let me just write 40 degrees here, get rid of this scratch work. Maybe I can make that a little bit cleaner there. And then let me write this in here as 40 degrees. Okay, let me make that better. So if we think about this guy right here, which is opposite of this angle A, I'm going to put lowercase a, and then this guy right here, which is your hypotenuse, it's opposite of this angle C, or the 90 degree angle, the right angle. So let's put lowercase c there for that, for the hypotenuse. So I would take the sine of 50 degrees. So let's say the sine of 50 degrees, and this is going to be the opposite, which is 5, over the hypotenuse, which is C. So this is one way that you can figure this out. Again, I'm going to go slow on this so nobody gets lost. I'm going to multiply both sides by C. So you would end up having this cancel. So you have 5 is equal to C times the sine of 50 degrees. If you want C by itself, you're going to divide both sides by the sine of 50 degrees. So let me divide over here. And so C is equal to, you're going to have this canceling, 5 over the sine of 50 degrees. So let me get rid of all this scratch work. Okay, we're going to punch this into the calculator. So C is approximately, let's say 6.5, if we round to the nearest tenth, so 6.5. Let me put this down here. So this is about 6.5. Let me get rid of this, and I'll just drag this up. Okay, so for this side A, there's a lot of different choices. I think it's better to work with this side here that was given versus work with this hypotenuse that you estimated. So lots of different choices here. What I'm going to do is use my tangent. So the tangent of this angle B would be the opposite over the adjacent. Okay, so I can say that the tangent of this angle, which is 50 degrees, is equal to the opposite, which is 5, over the adjacent, which is A. You could multiply both sides by A. So let me multiply both sides by A. And that's going to cancel this with this. And so you're going to have that A times the tangent of 50 degrees is equal to 5. You can divide both sides of the equation by the tangent of 50 degrees. And so we'll say that A is approximately, let me show this is canceling. We'll key this into the calculator. 5 divided by the tangent of 50 degrees. And I get about 4.2 if I round to the nearest tenth. So let me get rid of this, and let's put this here as 4.2. Okay, for problem number 8, now we have this angle and this angle very close to each other, Remember, this is the 90-degree angle right there. So if this is 90 degrees and this is 71 degrees, well, this guy right here is 90 degrees minus 71 degrees, which is 19 degrees. So let me write this down here so I can actually fit it. And I'll write that the measure of this angle B is going to be 19 degrees. So opposite of angle C, or my right angle, is the hypotenuse. We'll use lowercase c for that. And then opposite of my angle A, I'll use lowercase a for that. And so since I have this guy right here, which I would call the side lowercase b, it's got length 9, we'll go ahead and use that and say that for this 71-degree angle, this guy is going to be the adjacent side. So I could say that the cosine of 71 degrees is equal to your adjacent, which is 9, over your hypotenuse, which is c. And again, you could just multiply both sides by c. That would clear this denominator. So you have c times the cosine of 71 degrees is equal to 9. Then from there, you could divide both sides of the equation by the cosine of 71 degrees. So let's do that over here. Let me make that one a little bit better. So this would cancel. And so you're going to have c is equal to 9 over your cosine of 71 degrees. So let's key that into the calculator. And I get about 27.6 if I'm rounding to the nearest tenth. So we'll say c is approximately 27.6. Let me get rid of this and put 27.6 in there like that. Then for this guy, again, I'm going to use this side because this one is an estimate. You can do it if it's scratch work, but if you're handing this in, your teacher's probably going to want you to use this side because it was given and not estimated. If I use my 71-degree angle, I would have the opposite over the adjacent, so I could use tangent for that. So I could say that the tangent of this 71 degrees here is the opposite, which is A, over the adjacent, which is going to be 9. And so let me scooch this down just a little bit. I can multiply both sides by 9 so that I can clear this denominator here. So this is going to cancel. So you're going to have that A is equal to 9 times the tangent of 71 degrees. And let's plug this into our calculator. So 9 times the tangent of 71 degrees. And I get about 26.1 if I round to the nearest tenth. So we'll say A is approximately 26.1. So I'll erase this and just put that this is 26.1. Okay, let's take a look at problem number 9. So we have that a window is 30 feet above the street. The angle of elevation to the top of the building across the street is 50 degrees. And the angle of depression to the base of this building is 20 degrees. We're going to want to find the height of the building across the street. And here we're going to round your answer to the nearest foot. For this type of problem, or any word problem that you get in trigonometry, I always recommend making a rough sketch. The sketch does not have to be perfect. It's just for you to put some numbers down and visualize what's going on. So I've created this rough sketch. Not everything is accurate. So if you're trying to measure things with a protractor or something like that, it's not perfectly accurate, but it's good enough for us to get an idea of what's going on. So coming back up here, it says that a window is 30 feet above the street. So that's where you get this window here. And this is 30 feet above the street. And then it also tells us that the angle of elevation to the top of the building across the street is 50 degrees. So this right here would be your horizontal, and then this right here is your line of sight. So this angle right here, which is the angle of elevation, would be 50 degrees. And then lastly, you have this angle of depression to the base of the building, and this is going to be 20 degrees. So again, this is the horizontal here. This is your line of sight going down here to the base of the building. And this angle of depression here is 20 degrees. Okay, so how are we going to solve this problem? Again, what we're asked for here is the height of this building. So let's say from right here, going all the way down to right there. So that's what we need to figure out. Now, we know that from right here to right here, that's 30 feet. So in other words, the side for this guy right here, if I thought about it, would be 30 feet. Or you could just write 30 FT to abbreviate if you want to. So really, I only have to figure out the length of this side right here. And what I'm going to do for that is use my tangent function. So I will just go ahead and label this side right here that I'm trying to figure out as y. And I'm going to label this guy right here. I'm going to need this length right here as well. I'll say that that is x. Now, I could go through and solve this triangle here first, and then I could use that information to solve this triangle. But really, we don't need to do all that. If you're doing a word problem, I would suggest just doing the exact amount of work you need to solve the problem. And so what I'm going to end up doing here is first saying that if I think about this 20-degree angle here, well, the tangent of this 20-degree angle here would be what? Well, it's going to be your opposite, which is 30. Forget about the feet for right now. Over your adjacent, which is going to be your x. Now, what I could do is solve this for x. I'm going to multiply both sides by x, and I'm just going to cancel this away. So I have x times the tangent of 20 degrees is equal to 30. And then from here, I'm just going to divide both sides of the equation by the tangent of 20 degrees so that I can have x by itself. So let's write that like that. And then I'm going to cancel this with this. And so let me actually just erase this and write this up here. I'm just going to say that x is equal to, we're going to have 30 over the tangent of 20 degrees. You could punch this into your calculator and you would get about, let's say 82.4 if we round to the nearest tenth. But the problem is if you start rounding things and then you keep rounding things, you're going to end up with some errors. So I'm just going to represent x as this for right now. We're going to go back up and I'm going to think about this guy right here now. So if I want to figure out what is y, well, I could use my tangent of 50 degrees. Let me change my color here. So I could say the tangent of 50 degrees is equal to, again, this is y over x, or your opposite over your adjacent. So let's say y over x. Now, what I'm going to do is solve this for y, and then I'm just going to plug in for x. And this is going to allow us to have a more accurate answer because we didn't round twice. So what I'll do is multiply both sides by x here. And so that's going to give me, let me put a little border here, that y is equal to x times the tangent of 50 degrees. So let me get rid of this. And again, if you want to use an approximation, you can just take what you did here and put it in. Your answer will just be a little bit less accurate. So I'm going to say that y is equal to, I'm going to plug this right here in for x right there. That's all I'm doing. So 30 over the tangent of 20 degrees times the tangent of 50 degrees. Now we're just going to punch this into our calculator in one shot. That way we only round once. And I get approximately 98 point, let's say, we'll cut it off at 2. So 98.2. So let's go back up. And I'm going to say that y is approximately, let me get my yellow color here. So this is approximately 98.2. And this is in terms of feet. So this is in terms of feet. Now, if I take this guy right here, which is 98.2 feet, and I add it to this guy right here, which is 30 feet, that's going to give me 128.2 feet. So coming back, I would say that it's 128.2 feet, but we're specifically told to round your answer to the nearest foot. So you can just cut this part off, and we'll just say that as an estimate, it's about 128 feet. All right, let's take a look at problem number 10. So we have standing at the top of a radar tower, which is 200 feet high. The air traffic controller spotted a Navy fighter jet and a tugboat directly below the jet. The angle of elevation of the jet was exactly 25 degrees, while the angle of depression for the tugboat was exactly 32 degrees. What is the distance of the tugboat to the foot of the radar tower? And then also, what is the distance from the water to the jet? Round both answers to the nearest 10 feet. All right, so once again, if you get a problem like this, make a sketch. It does not have to be perfect. You're just putting something to where you can put some numbers in here and visualize what's going on. It's greatly going to help you solve this problem. So I'm just going to go through where everything in that sketch comes from. So the first thing is, it says standing at the top of a radar tower, which is 200 feet high. Now, it doesn't say on top, it says at the top. So I'm just going to say from right here to right here, that's 200 feet. And this is where my guy is going to be. And so coming back, it also says that you have these two things that he's seeing, right? So one is a jet, and then one is directly below, it's the tugboat. So with the angle of elevation for the jet, it's 25 degrees. And then for the angle of depression with this tugboat, it's 32 degrees. So coming back to the sketch, this is the horizontal here. And then this is the line of sight going to the jet. This is the line of sight going to your tugboat. So the angle of elevation here is 25 degrees. And the angle of depression here is 32 degrees. Let's go back up and think about the first question. So it specifically wants to know, what is the distance of the tugboat to the foot of the radar tower? So coming back, you've got your tugboat here, you've got your radar tower here. So let's grab maybe like a yellow pen, and I'll just draw this in here. And note that the sketch is not going to exactly match, but this distance from here to here should be the same distance from here to here. Okay, I know it's not perfect, but we're just going to have to go with that. So I'm going to say that the length of this guy is going to be x, and I'm going to put that the length of this guy is x. It's going to be the same thing. And I'm going to put that the length of this guy is y, just something I'm doing for right now. We know the length of this right here is going to match this. So this is 200. You could put feet if you want, or you could leave the units off and deal with it later. It's really up to you. And then what I'm going to do is actually form a right triangle here. And so I know that this guy right here would also be 200 feet. So let me put that in there. So the first task is to figure out what is x, or the length from right here to right here, this side. So you can think about the fact that this guy right here would be your 90-degree angle. And so we know that the measure of this angle plus the measure of this angle would have to be equal to 90 degrees, because this right here would be a right angle. So these angles would be complementary. So 90 degrees minus 32 degrees would give me 58 degrees for that angle there. And so this guy over here, if you wanted to fill it in, you don't need it, but if you wanted to fill it in, it's going to be 90 minus 58, which is 32, and this is in terms of degrees. Now, another way you could have gotten this, you could think about this as a transversal. We talked about this earlier in the course. This guy cutting through these two parallel lines here. And so this guy and this guy would be alternate interior angles. And then this guy and this guy would be alternate interior angles. So you know that this would be 58 degrees here, and that this is a right angle here. So this is 90 degrees. And again, you could do this up here. So let me try to match this as best as I can. So this is 90 degrees. And of course, if you want to put this in here, 90 minus 25 is 65. So this is 65 degrees. And you don't need all these angles. I'm just filling this in completely because this is a more complicated problem. So thinking about this, how could we figure out what is x? Well, we know that we have a side here. It's 200, or 200 feet if you want to say that. And essentially I could use this angle or this angle. I'm going to go ahead and use this 32-degree angle here. And I'm going to use this side and this side. So I have the opposite and I have the adjacent. So we would use our tangent function there. So we would say that we have the tangent of our 32-degree angle is equal to, again, this is opposite, which is 200, forget about the feet for right now, over this guy, which is x, that's your adjacent. Let me grab this. I'm going to paste this in here and do my scratch work. So I'm just going to solve this for x, and I'm going to first multiply both sides by x, cancel this away, and we'll have that x times the tangent of 32 degrees is equal to 200. Let me erase this. I don't think we need it anymore. I'm going to divide both sides of the equation by the tangent of 32 degrees. And so what this is going to do is cancel this with this and say that x is equal to 200 over the tangent of 32 degrees. So this would be approximately 320, let's go 0.0, and I'll go ahead and say 7. We're going to end up rounding this, but I'm just going to keep this for right now. Let me get rid of this, and we'll go back up. And for right now, I'm going to say that this is approximately 320 feet. Okay, so approximately. And you could put that in here too as well. So x is approximately 320 feet. This is the answer for the first guy. So coming up here, to answer this question for the first one, I'm going to put 320. Remember, this was 0.07 feet. And then it told us here to round to the nearest 10 feet. Well, what does that mean? Well, think about your place value. When you think about this, this is the ones place. This is the tens place, right? So to the nearest 10 feet, I want to look at this digit right here. And in this case, it falls in the category of 4 or less. So I'm going to keep this digit, this 2, unchanged. And I would make this into a 0, but it's already a 0. So really all I have to do is just cut this part off and say this is 320 feet if I want to round this to the nearest 10 feet. Now the next part is, what is the distance from the water to the jet? So let me unhighlight this and let me highlight this now. So what is the distance from the water to the jet? So coming back, what we're trying to figure out here is from right here all the way up to right here. So in other words, you need to figure out what y is, and then you need to add 200 feet to that, and then we're going to round. Okay, so what I'm going to use here is this angle here, which is 25 degrees. And again, I'm going to use my y over x, which is my tangent function. So I'm going to say that I have the tangent of 25 degrees is equal to y over x. Here's where you have to make a decision based on the course that you're in. If you're self-studying, then you could just plug in this approximation. It really doesn't matter, right? It's going to be about the same. If you're in a course and your teacher tells you to be as accurate as possible, well, instead of plugging this in for x, I would use this guy right here. That way you're only rounding once. So that's how I'm going to do this. And I'm going to multiply both sides by x here, just like we did in the last problem. So you see y is equal to, you have x, which I'm going to plug this in for x. So x times the tangent of 25 degrees, like that. We can get rid of this. And essentially all I'm going to do is just plug in for x. So I'm going to plug this in right there. So y is equal to, I'm going to say this is 200 over the tangent of 32 degrees times the tangent of 25 degrees. So let's punch that into the calculator, and let me make this symbol a little bit better here. So this is about or approximately 149, let's say 0.25. I'm just going to cut it off there. So I'll say this is approximately 149.25. And then let me put feet there. Now again, we need to take this 200 feet and add it to this 149.25 feet, and that will give me 349.25 feet. So coming back up, I'm just going to put a comma, and I'm going to put 349.25 feet. But again, we are specifically told to round both answers to the nearest 10 feet. So I'm going to look at the digit in the tens place, so that's a 4. The digit that follows here is a 9. So that tells me that I want to add 1 to the 4. So that would become a 5. And then I would replace everything else with a 0. You can just cut these guys off. So this would end up being a rounded answer of 350 feet.